In this video, I'm going to show you why a proof by contrapositive works. And to do this, I'm going to use a truth table. Now, there may be some confusion when you can use a truth table and when you cannot. And so when you don't have any quantified statements, when you don't use quantifiers, you can use a truth table. But as soon as you have quantifiers, as soon as you're saying for all x, then you need a proof. You can't just use a truth table when there's a quantifier. As soon as we get quantifiers, truth tables don't work anymore. So I'm not going to use any quantifiers to tell you why a proof by contrapositive works. The reason that a proof by contrapositive works is purely logical, purely symbolic logic. So we don't need an actual proof. We just need a truth table. Okay, so for our truth table, now I guess before I do, so I'll just say what the contrapositive is. The contrapositive of P implies Q is not Q implies not P. And what I'm going to show you is that P implies Q and not Q implies not P are logically equivalent. Meaning that no matter what truth values are assigned to P and Q, they have the same final column in the truth table. So P, Q, not Q, not P, P implies Q, not Q implies not P. True, true, false, false, true, false, true, false. There I'm just exhausting all possible truth values. Okay, so not Q, right, we'll just negate. So false, true, true. And not P, false, false, true, true. Now P implies Q, right, we're looking in these two columns here. Remember, we only get false when we have true P and false Q. So false there, true, true, and true. And now for not Q implies not P, we're looking at these two columns here. Remember, we only get false when we have not Q is true and not P is false. So we get false here. Let's see, false. So not Q is false there and there. So immediately those are true. And here we have true, true, so we get true. And you see that these two columns are the same. So what that means is that if you use not Q implies not P to prove something, then it's the same as using P implies Q and vice versa. So logically equivalent.